Hello my dear students. Today we are going to present different types of questions and problems which is going to revise on the whole syllabus in this year, and we are going to discuss their explanation in details. So let us start. Consider the following standard electrode potential. This next question here gives the different oxidation potentials for three elements: zinc and chloride ion and magnesium. And according to these reactions, we find that the magnesium has the highest oxidation potential and chloride ion has the lowest oxidation potential. So what will happen when zinc powder is added to aqueous solution of magnesium chloride? No reaction take place, or chlorine gas will produce, or magnesium metal will form, or zinc chloride will form. Here, my dear student, the answer it will be no reaction will take place, as the oxidation potential of zinc 0.76 volt is less than that of magnesium 2.37 volt. So zinc is less active than magnesium. So zinc cannot replace magnesium in magnesium chloride solution. Next question. All the following ions are paramagnetic and color except what? Is it vanadium positive 2, copper positive 2, copper positive 1, iron positive 2? If you think about the answer of this question, it will be copper positive 1. The electronic configuration of these ions as shown on the screen: vanadium positive 2 has 3 unpaired electrons, iron positive 2 has 4 unpaired electrons, copper positive 1 has 0 unpaired electrons, no unpaired electrons, and copper positive 2 has 1 unpaired electrons. We know that the unpaired electrons determine the magnetic property and the color property. When we know unpaired electrons, when there is no unpaired electrons, the compound is colorless and diamagnetic. So the answer here it will be copper positive 1, as it has no unpaired electrons. Next question. The solution which doesn't form black precipitate with hydrogen sulfide gas, if it is passed in it, is silver nitrate, lead acetate, sodium chloride, copper nitrate. If you think about it, yes, it will be sodium chloride, as it doesn't form precipitate. All we know that sodium ions, that sodium salts, all soluble in water, doesn't give precipitate at all. Next one. On adding ammonium cycyanate solution to compound X, it exhibits blood red color. And when ammonium hydroxide is added to the same compound, a reddish brown precipitate is formed. The compound X is what? Is it iron 3 chloride, iron 2 sulfate, iron 3 nitrate? The answer it will be iron 3 nitrate. We know that iron 3 nitrate, when it reacts with ammonium cycyanate, it gives here iron 3 cycyanate, which is blood red color, and ammonium nitrate. So the blood red color here formed of iron 3 cycyanate. And when adding iron 3 nitrate to ammonia solution or ammonium hydroxide, it gives ammonium nitrate and reddish brown precipitate of iron 3 hydroxide. So the reddish brown precipitate is iron 3 hydroxide. So iron 3 nitrate is responsible for these two colors. Next question. In the following exothermic reaction, 2SO2 plus O2 gives 2SO3. The proper conditions for increasing the yield of SO3 gas, what are they? Before looking at the choice, if you look at the question here, the reaction here is exothermic. So the heat coming with the product. So by decreasing the heat, the reaction shifts forward, forming more SO3 gas. And here, as the number of moles of reactants are 3 and number of moles of products are 2, and increasing the pressure shifts the reaction forward, giving more SO3. So if you look at the choices, increase pressure and raising temperature, decreasing pressure, raising temperature, increasing pressure, lowering temperature, decreasing pressure and lowering temperature. So the right answer is increasing pressure and lowering the temperature. Next question. Alcohol G is oxidized by acidified potassium dichromate solution, forming acid H. The reaction of alcohol G with the acid H yields the ester. Which one here? Is it number A, HCOOC5H11, or CH3COOC4H9, or C2H5COOC3H7, or C3H7COOC2H5? If you are going to think about this question, the alcohol is oxidized and then react with alcohol again, giving acid, and react with alcohol to give ester. So the acid produced must with the same number of carbon atoms. So the choice C is the right answer. As propanoic acid, as shown in the figure, C2H5COOH reacts with propyl alcohol, C3H7OH. It gives here propyl propanoate, C2H5, COO, C3H7, and water is produced. Next question. The isotopic nomenclature of this compound, CH3CH, C2H5COH, is it 2-ethyl propanoic acid, pentanoic acid, 2-methyl butanoic acid, 2-ethyl butanoic acid? To write the isotopic name for this compound, we have to numbering the acid starting from the carboxyl group and take the longest chain. So the answer here will be 2-methyl butanoic acid. Next question. Which of the following statements about aspirin is incorrect? Where is the atomic mass of sodium 23, carbon 12, and oxygen 16? 1 mole of it reacts with 1 mole of sodium hydroxide solution. 2 mole of it reacts completely with 106 grams of sodium carbonate solution. It is formed from the reaction of salicylic acid with ethanol. It turns the color of bromothymol blue into yellow. If you think about this question, the wrong one here, it is formed from reaction of salicylic acid with ethanol, because the right answer, it is formed from the reaction of salicylic acid with acetic acid. The preparation of aspirin, here salicylic acid reacts with acetic acid, and then removing water from their reaction, so giving the aspirin, which is acetyl salicylic acid, and water is produced. So the reaction of aspirin with sodium hydroxide, as the aspirin reacts with sodium hydroxide as shown in the graph, so it gives sodium acetyl salicylate as shown in the graph, and water is produced. So 1 mole reacts with the aspirin. And the reaction of aspirin with sodium carbonate, as it contains carboxyl group, so reacts with sodium carbonate, Na2CO3, reacts 2 moles of it react with 1 mole of sodium carbonate. So here it produces sodium acetyl salicylate and carbon dioxide and water. So the molar mass of sodium carbonate, which is the mass of 1 mole of sodium carbonate that reacts with the aspirin, 2 times 23 plus 12 plus 3 times 16 gives 100 gram. Next question. On heating iron to oxalate in air and treating the product with carbon monoxide gas at 270 degrees, what is produced? Magnetic iron oxide, iron 2 oxide, iron 3 oxide, siderite. If you think about the question, it will be magnetic iron oxide. Here, the next question. When heating iron to redness and then passing the steam on it, the product A is formed, and when hot concentrated sulfuric acid is added to compound A, products are formed, which are what? Iron 2 sulfate and water, iron 3 sulfate and water, iron 2 sulfate and iron 3 sulfate and hydrogen, iron 2 sulfate and iron 3 sulfate and water. The right answer here, it will be iron 2 sulfate and iron 3 sulfate as a reaction between magnetic iron oxide and the hot concentrate sulfuric acid. Here, iron reacts with water vapor at 500 degrees, gives the magnetic iron oxide and releasing hydrogen gas. Then magnetic iron oxide reacts with sulfuric acid, concentrated and heat. It gives iron 2 sulfate and iron 3 sulfate and water. What is formed on strong heating? The precipitate formed from the reaction of iron 3 chloride with ammonia solution. Is it iron 3 hydroxide, magnetic iron oxide, iron 3 oxide, iron 2 oxide? If you think about the answer, yes, it will be iron 3 oxide. Here, when iron 3 chloride reacts with ammonium hydroxide, it gives ammonium chloride and reddish brown precipitate of iron 3 hydroxide. Then heating strongly iron 3 hydroxide above 200 degrees, it gives iron 3 oxide and vapor is produced. Next question. When iron reacts with dilute sulfuric acid, iron 2 sulfate is formed, not iron 3 sulfate. What is the reason for that? Is it iron 2 ion is more stable? The evolved hydrogen gas is reducing agent? Dilute sulfuric acid is oxidizing agent? Iron 3 ion is not stable. The reason? Because the evolved hydrogen gas is reducing agent. Next question. In the same period of transition elements as the atomic number increase, what? Its ionization energy decrease, its diameter increase, it is difficult to be oxidized, or its density decrease. If you think about the answer, it will be it is difficult to be oxidized. Next question. The element in which the outer levels have the electronic configuration 5f14, 6d6, 7s2 is from what type of transition series? Is it first, fourth, second, inner lanthanides? If you think about the question, it will be 6d, so it will be fourth transition series. The next type of choose questions gives the IUPAC name. Here, this compound as shown on the screen, its name is 3-ethyl 2-methyl pentane, or 3-ethyl 4-methyl pentane, or 2-methyl 3-ethyl pentane, or 4-methyl 3-ethyl pentane. If you are going to name this compound, we have to start with the end with nearest to the branch. So it will be from 1 till 5. So here the correct name, it will be 3-ethyl 2-methyl pentane. Next one. As this molecule shown on the screen, is it 3-hydroxy-2-chloropentanoic acid, 3-hydroxy-4-chloropentanoic acid, 2-chloro-3-hydroxypentanoic acid, 4-chloro-3-hydroxypentanoic acid. If you are going to numbering this chain of the acids, we have to start from the carboxylic group. So the correct name, it will be 2-chloro-3-hydroxypentanoic acid. Another example, here if you are going to name this compound, is it 2-chloro-3-pentanol, 4-chloro-3-pentanol, 4-chloro-3-ethyl 3-propanol, or 2-chloro-3-ethyl 3-propanol. Here you are going to numbering the carbon atoms for the longest chain, starts from the nearest to the branch. So its name, it will be 2-chloro-3-pentanol as the hydroxyl group at carbon number 3. Next one. Here, if you are going to name this compound, is it 1-chloro-3-pentene, 5-chloro-3-pentene, 5-chloro-2-pentene, 1-chloro-3-pentene? you are going to numbering the carbon atom nearest to the unsaturation here, which will be double bond. So the right name for this compound, it will be 5-chloro-2-pentene. Another compound here, if you look at the screen, is it 3-methyl-2-pentyne, 3-ethyl-1-pentyne, 3-ethyl-2-butene, or 3-methyl-1-pentyne? If you are going to name it, that starting the numbering from the unsaturation carbon, here we find that the right name, it will be 3-methyl-1-pentyne. Also, this cyclic compound, its name is it 3-bromo-1-chlorocyclopentane, 4-bromo-1-chlorocyclopentane, 1-bromo-3-chlorocyclopentane, 4-bromo-1-chloro-1-cyclopentane. Here, the unsaturation we have going to numbering from the unsaturation carbon that gives the lowest position for the unsaturation for substitution. So here, the correct name, it will be 3-bromo-1-chloro-1-cyclopentene. Another example here, if you look at this molecule and numbering the carbon atom from start nearest to the unsaturation, so here its name, it will be, is it 3-bromo-phenyl-1-pentene, or 3-bromo-2-phenyl-1-pentene, or 3-bromo-2-phenyl-4-phenyl-2-pentene, or 3-bromo-4-phenyl-2-pentene? The right answer here, it will be 3-bromo-2-phenyl-1-pentene. Next type of choose questions, which are problems. On oxidation of 0.5 gram of magnetite ore Fe3O4 into iron 3 oxide, 0.411 gram of iron 3 oxide is produced. The consumed mass of magnetic iron oxide is what? Given the atomic mass of iron 56, oxygen equals 16. Here, is it 0.7946 or 39.97 or 0.1986 or 0.3973? If you solve the problem, it will be 0.3973. What are the steps for this problem? The solution. Here, as we write the equation, 2 moles of magnetic iron oxide on oxidation gives 3 moles of iron 3 oxide. So the ratio of these moles of magnetic iron oxide and iron 3 oxide 2 to 3. So converting both of them into mass, so as shown on the screen, 464 gram gives 480 gram. Then x gram here will give 0.411 gram of iron 3 oxide. So the mass of iron 3 oxide, the magnetic iron oxide, will be 0.411 times 464 over 480, so equals 0.39373 gram. What are the percentage of black oxide, magnetic iron oxide in the ore? Is it here these values of A, B, or C, or D? If you solve it, you will find it will be 79.46. How can we solve this through? Here the solution of this problem, the percentage of magnetic iron oxide is the mass of produced or consumed, the consumed magnetic iron oxide over the mass of the ore times 100. So the mass of consumed magnetic over the mass of the ore times 100, it will give the percentage 79.46%. Next problem. The molar mass of a base MOH2 that 2.05 gram of it react with 24 milliliter of 1 molar hydrochloric acid. What is the correct answer here? Is it A, chemical equation of the acid with the base MOH2? It gives the salt MCl2 where M is unknown element and 2 water reduced. So here we apply the ratio M1V1 over Na equal the mass of the compound of the base MOH over its molar mass times its number of moles in the balanced equation. So by substituting their values of the acid and the base, we can get the molar mass of the base. as shown on the screen. So the molar mass of the base will equal to 2 times 2.05 over 24 times 10 power negative 3, so equal 170.8 gram. Next problem. Sodium salt solution is added to barium chloride until complete precipitation of white precipitate that insoluble in dilute hydrochloric acid. Then after filtration and drying the precipitated, its mass is 2 gram. So the reacted sodium salt is what? Is it phosphate, sulfide, nitrate, sulfate? If you think about it, yes, it will be sulfate, as the barium sulfate formed is insoluble in dilute hydrochloric acid. Here, the mass of barium chloride in the solution is what? Is it here by knowing the atomic mass of oxygen, sulfur, and chlorine, and barium? Is it these values of A, B, C, D? If you solve the problem, it will be number B. How can we solve this problem? Here's the solution. As barium chloride reacts with sodium sulfate, as we know the sodium salt is sulfate, as the formed precipitate barium sulfate is insoluble in dilute hydrochloric acid, so the ratio of barium chloride with barium sulfate, 1 mole of barium chloride gives 1 mole of barium sulfate. So by getting the molar mass of the barium chloride and barium sulfate as shown in the figure, so the ratio of the mass that of barium chloride that produce 2 gram of barium sulfate, so mass of barium chloride here equal, here as shown in the screen, equal 1.785 gram. Next problem. If the degree of dissociation of weak organic monoprotic acid is 3% in 0.2 molar solution, the ionization constant of the acid is what? Is it question is choice number A or B or C or D? It will be A, 1.8 times 10 power negative 4. The solution for this, as we know that alpha equals the percent over 100, so equal 0.03, and so Ke equal alpha square times C. So by substituting the values of alpha and getting the square time concentration, so it will be Ka here equal 1.8 times 10 to power negative 4. Next problem. If the solubility product of bismuth sulfide KSB 1.7 times 10 to power negative 7, 10 power negative 10, its solubility degree is what? Is it 4.35 times 10 power negative 3 or 4.35 or 4.35 times 10 power 3 or 4.35 times 10 power negative 4? The answer will be A. How can we solve this problem? The solution. Here we know that bismuth sulfide that gives 2 bismuth ion and 3 moles of sulfide ion. So KSB here equal 2x, which is the degree of solubility here, 2x power 2 times 3x power 3. So 1.7 times 10 to power negative 10 equal 108 times x power 5. So x root 5 for the value of the KSB over the 108. So it will be 4.35 times 10 to power negative 3 molar. Next type of questions. From the following experiments, deduce the salt name and its chemical formula without writing chemical equation. The salt solution, which forms white precipitate on adding lead to acetate solution to it, and it forms white gelatinous precipitate on adding ammonia solution to it, is what? Is it aluminium sulfate, iron 3 sulfate, calcium phosphate, aluminium sulfate? If you think about it, yes, it will be aluminium sulfate salt. Next one, the salt solution, which forms white precipitate that turns violet when exposed to light on adding silver nitrate to it, which is chloride ion, and on adding ammonium carbonate solution to it forms white precipitate, which is calcium ion. So what is the salt name? Calcium chloride, or iron 3 nitrate or calcium phosphate or calcium of copper sulfate. So the answer here, it will be calcium chloride. Next one. The salt which removes the brown color of iodine solution. Here the removed color of iodine solution, it will be thiosulfate radical. And on adding hydrogen sulfide gas to it in the presence of dilute hydrochloric acid forms black precipitate, which is copper ion, that's soluble in hot conc nitric acid. So what the salt is? Is it copper thiosulfate, aluminum nitrate, calcium phosphate, copper sulfide? If you think about it, yes, it will be copper thiosulfate. Next one. The salt solution which gives colorless gas that gives white fumes with paper wetted with ammonia solution. Here, the white fumes here that turns paper wet with ammonia solution here to white fumes, it will be chloride ion. And on adding hot concentrated sulfuric acid to it, and also on adding sodium hydroxide solution, it forms reddish brown precipitate, so it will be iron 3 ion. So here the salt is iron 3 chloride or calcium sulfide or aluminum sulfate or iron 2 sulfide. Yes, it will be iron 3 chloride. Sulfuric acid with a chloride salt gives here the colorless gas, turns paper wet with ammonia solution to white fumes. And the iron 3 salt gives here with sodium hydroxide reddish brown precipitate. So the answer is iron 3 chloride. My dear students, we have reached to the end of our program today. I hope you understood all the points and different types of questions and the problems that we discussed today. And so till we meet again, my best wishes for you.